let's have a look in your booklet. If you find those two shaded areas combined, they've given you the area is 8. They want you to find the value of k, so we're working backwards. Okay? Now, the reason why I want to go through this question is there are two ways to do this. Okay? In the solutions, girls, they've subtracted the two areas where they did this curve above, take away the curve below, which makes sense, all right? You can subtract them. When you subtract them, you can basically put the two equations together like this. So this part of the curve comes from which equation, girls? Yep, so k minus...
k1 minus x squared.
Yeah, so k minus kx squared, take away. I'm just expanding the bracket out, is that all right? Yeah? And girls, the easiest way to do this, listening please, is to find the area from 0 to 1 and then times the whole thing by 2 because there are symmetrical areas. Make sense? This is the easier way, okay? But I wanted to show you how would you do this question if you added the two areas, because whether you subtract these two areas or whether you add these two areas, you're still going to get the same answer. Is that not correct? If I subtract these two areas, there's no areas in common that you're subtracting. So if you subtract these two areas, you're still finding those two together, whether you subtract or add or not. So whether you add or subtract. Can we agree upon that first? Yeah? So I wanted to show you how to do it if you were to add those two areas. Okay? Now, if you were to add those two areas, you got to do it separately. Okay, sorry, hold on. Girls, I'm going to call this area 1. I'm going to call this area 2. How do I find area 1? 0 to 1. What do I find it under? What curve is that under? The blue one. K minus kx squared. And then times it by 2 to get that part of the area, correct? Yeah? Now, area 2, you still times the bottom area by 2 from 1 to 0, but it's under this one. Okay? Now, what you want to do is you actually want to evaluate these two separately. And that's the question I have for you guys, and that's the technique why it didn't work before Grace. Why do I need to do these two separately instead of adding the two equations together like we did if we were to subtract it? What's wrong with adding them as one equation? That's my question to you girls, and I want you to think about it. Sorry? Not that. Girls, think about the area below and above the x-axis. Yeah? Girls, this is above the x-axis. This is below the x-axis. Any area that you find below the x-axis, you're going to get negative. That's why. Okay? So when you add areas where you have two different areas above and below the x-axis, you've got to do it separately, not put the two equations together like I did here. So in fact, if you evaluate this, you're going to get 4k over 3 positive. This is fine because that's above. So this is the area to this. But the area below, if you actually evaluate it, you're going to get minus 8k over 3. That's why you can't add the two equations together, just like if you were to subtract it. Now, girls, to now finally find the value of k, if you get a negative, you want to always absolute it. Yeah? So the final answer to this is 4k over 3 plus 8k over 3. And what does the area equal to? What does it say? 8. The area says it's 8 in the region. So if you evaluate this, you're going to get k equals to 2. That's why it didn't work if you try and add the two equations together. Don't add equations together if you have areas below and above the x-axis. But you can subtract it together if you're subtracting it. So my preference is to subtract the curve above, take away below as one equation. That's the easiest way, but I wanted to show you how it works if you were to add it. Can you read the question from there?
Yeah.
So it says show that the area of the shaded region is that. All right? So obviously that's the area here. They don't give you that actual point, but the answer is 3. How do you get that point? How do I find that point 3? Because they haven't given you that point. They actually want you to figure it out. Yeah, so if you make y equals to 0, yeah, so that's just 2 to the power of x equals to 8, and obviously x equals to 3, which is pretty straightforward. Okay, so the area is from 0 to 3. Now this comes back to exponential again, girls. We're integrating 8 minus 2 to the power of x, aren't we? Yeah? But how do I integrate 2 to the power of x? It's you integrating that. Yeah?
Let's go.
So this is then 8x. Take away, how do I integrate that again? 1 over. Is that alright? If you do this, girls, you're going to get the answer, which is this is actually the easy part. Yeah? Now, it's the next part I wanted to address. Girls, a new function g of x is found by taking the graph of minus f bracket minus x and translating it 5 units to the right. They want you to sketch that, and then after that, they want you to actually find the area of that. Okay, so here's how you do it. Let's see our transformation. Girls, this is our current f of x. So let's draw what's inside the bracket first. What are we doing if it's a minus x in there? Do you girls remember what we do?
On the y-axis. Either one.
It's actually this.
That's what I said. I thought it changed the thing on the y-axis.
Yeah? Now from here, I'll do it in red. And then from here, if I want negative of that, that's obviously this. That'll be that. And then after that, what do they do on top of that?
You translate it.
5 units to the right, yeah? So that means this minus 3 is going to come at 2. It's going to be that, but what's the end point though? See how I've got a 3? Well, why is it from 2 to what though?
3.
Try again.
Oh.
It's actually up until 5. So that's the area that they want you to find. 2 to 5. Because you're moving it, translating it 3 units to the right.
So it's 3 to 0, right? Ah, okay.
Yeah? So that's the area that they want you to find. So, the first thing you got to notice, girls, that area is exactly the same as that area. Can you see that visually?
Yes.
Yeah? But here's the tricky part. So I've done the second part. Now the third part. But because it's area below the x-axis, what do I need to apply? Sorry? Negative. So the answer to that is, girls, you put a negative on this. That's the answer.
What's an absolute?
So girls, this is the answer to area of g of x. Oh, no, they want you to evaluate, sorry.
What?
Oh, no, they want you to find the exact value of. Doesn't mean find the area. If they want you to find the exact value of, give me the area number in terms of positive or negative. That's the tricky part. Yeah? If they want you to, they're basically asking you to evaluate it, not find the area. So evaluating means just finding the integral, not the area, which means you're taking the negative sign of it.
With area, you have to have
Yeah. Yeah? Now, I want to actually go a bit further from here because I saw a multiple choice trial paper question which got me and I had no idea how to do it. Girls, what we've just found, this is the area of, what if I asked you to find the area of this? So, sorry, the area of this, girls, is this. Yeah, we all good? Yeah? But if they asked you from here, find the area if it was 1, take away that. What does 1, I'll make it more clear for you. What does plus 1 imply to? That's right. That implies from the graph that we have, you're actually moving the graph up by 1. So you're actually going to get a smaller area under x-axis, aren't you? Yeah. But how do I get that exact area? Here's a technique that I don't want you to forget. Girls, let me rewrite it.
Yeah, 1 minus everything.
Girls, if I just, girls, this is important, if I just integrate 1, just look at that. If I just integrate 1, what do you get? X. Yeah? And what are we evaluating that x from? What's my current area from? What point to another?
2 to 5.
2 to 5, right? So the answer is 5 take away 2, which is? 3. So the answer to this is this plus 3. That's how you do it. Which is pretty cool. So the answer, so 7 ln 2 take away 21. So that would be the area if you translated the graph 1 unit up.